before we hand over, oh, we have one more there.
Do you know about any projects for fully autonomic Arduino?
That's what we're going to hear about very soon.
Patience.
Yes. Patience, my Padawan. So, my name is Micke Askernäs. I'm from Sweden. I hope you enjoyed this first part. So I'm going to hand off to my colleague Björn Giesler. Please give him a very nice hand.
Thank you very much. Thank you, Micke. I'm going to have a hard time matching that talk. Just give me 1 second. Switch to a different presentation. There we go. Right. Who was the guy who just asked the question? Okay, perfect. So this is precisely what I'm going to talk about. Before I do that, let me basically reiterate what Micke just said. When I started building my Droid, I'm a software guy. I had no idea of circuit boards. I had no idea of how to wire up something like that to build it. And it took about a year or a year and a half to come to that kind of knowledge. The first step was, oh, so it just hooks up like that. Second step was bang. Okay, obviously, so it doesn't. Buy the stuff again. And also reiterate what the question about the price. The 10,000 euro is probably right for my Droid as well, and that's what's in there now. The components that I've fried along the way is probably another matter entirely. Okay, so I'd like to talk about autonomous droiding. And I'd like to start again with the question of safety. One thing that I've learned, or no, let me, since a couple of you were in the audience yesterday when we were talking about Droid Building 101, you've heard that there are a couple of materials that you can build a Droid out of. One is wood, one is aluminum, one is styrene. And Oliver, who was giving the talk, kind of said, okay, so the aluminum one is the luxury one, and the styrene one, which Björn built, is kind of the El Cheapo version, and you can get by with very little money. And I was like, yeah, it's kind of true, but it's not exactly the reason why I built my Droid out of styrene. I worked at the robotics lab 5 or 6 years ago, and we had a huge Droid, I think 350 kilo, which had emergency stops on all sides. And somebody had the great idea to just hook up a touch sensor to it as a demo, where you can just push the robot and it would, the whole 350 kilos would slide along as if it weighed nothing. It was a blast at all the exhibitions because the professors had a lot of fun, just standing there like this, and another guy on the other end going like this, and pushing people with this robot all through the hallways. Now, one time, some students crossed the wire on that robot, and it made off through the lab wall into the emergency stop. So it went through half of the drywall with a metal, large metal bearing in the middle, pushed its own emergency stop, and now we had it in this drywall. And we said, okay, the humorous thing about it is how are we going to get this thing out of there? The non-humorous thing is, if somebody had been standing there, he would have been pushed into the drywall. So you do not want a really heavy robot on autonomous control while you're still developing it. And personally, I wouldn't even want a really heavy robot on autonomous control that's bought out of the store, because things go wrong. So one essential measure about if you want to build an autonomous robot or an autonomous droid, build it light. If it's 15 or 20 kilos and it goes haywire, you can just put your arm out and hold it. If it's 150 kilos, you're going to have a hard time with that. And if it goes haywire in the crowds down there, you don't want that at all, absolutely. Next thing is built-in software safety. And that's why I'm still using this old thing, because yeah, it's ugly, but it's absolutely proven. Those things fly model helicopters with turbines, so they don't fail. So if you know that the connection is lost to this remote control, you know it's not coming back because the remote control is gone. And if you know that if you put a channel to some value on the remote control, you know that the droid is going to receive it. Third box I haven't put on here, but if you come over to my Droid at the end of the talk, you'll see it has these funny switches on the battery boxes. I can actually switch off the power to the motors. So if I put it somewhere, I switch off the entire drivetrain, and the rest is still working. Okay, so much as a matter of safety. Now, if you want to do autonomous robotics, I mean, we're as a club, we're venturing into territory where no man has gone before. Excuse me, wrong convention. And we do stuff that you cannot buy off the shelf right now. If you just want a basic remote control droid, you can buy that. You can buy parts off the shelf, and you can read through a wiki page that tells you how to construct it and how to route the wires so that nothing goes bang. But if you want to build something autonomous or automated, we're currently trying to get the stuff onto computing platforms that everybody can buy out there. So we're trying to modularize, we're trying to make our own circuit boards that you can actually buy from members of the club, so that you don't have to do every step yourself, but it's still a path that's trodden, but it's not paved. So I kind of foresaw the question, what hardware do you use to build an autonomous robot? So I put on what's basically cruising around the forums in terms of new and up-and-coming hardware. We have the Arduino, we have the Raspberry Pi, we have something that's pretty new, that's the Droid U2, and we have a full-fledged PC. It's basically a scale from left to right. You can spend more money going right. You get more computing power, obviously, but you also lose a couple of things. So let's, for example, take the Arduino. It's a pretty cheap thing. It's controllable in C or C++. It's got very low power consumption. The thing it has is it has analog and digital I/O ports. So you can actually say put voltage to this wire, and if you have some component on the other end that works with voltage and not with a USB cable or with an Ethernet cable, it will understand that. And all the RC components, all the motor controllers usually work with that kind of information. So you want a circuit board in the Droid that can actually talk to this kind of hardware. So that's why most of us use Arduinos or similar microcontrollers as the basis of everything. You could do that with the Raspberry Pi as well, because someone asked the question. It's a bit, Raspberry Pi is basically a regular PC in a very small package. It's pretty cheap. It has analog and digital I/O pins, but be careful with them, because with an Arduino, if you fry something, you usually fry one pin, and the whole thing still works. And it's really hard to make a critical mistake with an Arduino. With the Raspberry Pi, if you do something wrong, if you cross two wires, then the whole circuit is blown, you have to buy another one. And you can use a full-fledged PC, but that doesn't have analog and digital I/O pins, so you still need some components in there to talk to the hardware. So that's where the talk about multiple computers in the same Droid comes from. They're all computers, they just have different capabilities. Oh, that went wrong. Oh my. All right, I'll try to reconstruct that slide as I go along. Okay, so what we've just heard about is the conventional control for a Droid, where you have a remote control. It could be a Spectrum, it could be Micke's R-series controller that talks in some way to a hardware controller, and that talks in turn to motor controllers, and they talk to the motors themselves. So this is the basic architecture. I've called it conventional, even if you can put lots into there. But this is still automation, and it's not autonomy. Now for autonomy, you need something more, you need a control architecture on top. And this control will probably be a PC of some kind. And I hate to break it to you, if you want to do autonomous droiding, you will have to learn programming if you don't already, if you can't already program, because you're going to have to do a lot of that yourself. The control PC will talk to the hardware controller as if it were a remote control. So it's basically exactly the same this way and that way, even if it uses a different protocol. And the control PC will also take some sensors, sensor readings, and look at the environment, look what's going on there. Okay, now the thing is, the stuff down there, if you look at the different droids we have in the club, the control structure underneath, you find wildly different stuff. You find homebrew stuff, you find the regular remote control stuff that Micke talked about in the beginning. Everybody does their own thing. Now what you need is, software-wise, is a robot interface, because you want to be able, for the control PC, to talk to different architectures down there. And that's what is running in my Droid, and that's what I'm trying to standardize over the next, say, 1 or 2 years, is exactly this part of the robot interface. I want people to be able to download a software package from the internet that says you can put this in a Droid, you can put up a couple of switches and a couple of configure options, and it will talk to your Droid architecture, and then you can build your own behavior, reasoning, and stuff up there. All right. The software I'm using for that is ROS. Who's heard of ROS? Right. Okay. The thing is called Robot Operating System. It's basically a software package running on top of Linux, which has a wildly steep learning curve. It really takes a long while to get into. But it's very, very powerful, and it's used by many robots worldwide at different universities and also industry sites. Actually, I've driven a Bosch autonomous vehicle, I think 3 months or 4 months ago. They use ROS as the basic operating system for their car, and they use software packages originally written by Carnegie Mellon and Stanford University. They brought that into their car, changed a couple of parameters, and the car was able to drive autonomously. They've changed now basically everything they downloaded, but that was the basis. The thing is, that's free and open source, and now it has a couple of very useful standard components. What you've seen in the beginning, when I had my Droid following me around this, along this hallway here, was person tracking running on top of a 3D sensor like the Microsoft Kinect. And that's a standard component that's in ROS. You can just download that and write a couple of lines of code to interface it to your Droid, and it will work. It also has voice input, which you saw spectacularly fail at the beginning. But that's not the fault of the voice input. It's just the fault of my code that doesn't interpret correctly what I've actually said. It has components for mapping, obstacle avoidance, and so on and so on. Now, this gets really technical, but it's also over in a pinch. So let's get it over with. The thing with ROS is, the idea is you have a robot that's not controlled by one big master program, but it's controlled by a couple of interlocking nodes. So if you want a droid that follows you by tracking you in a 3D camera and also turns the head and also reacts to voice control, you don't write one big program, but you write one voice control node and you write one person tracking node, and it's much faster, and you don't have to do the whole thing at once. You could do a standing model that just turns the dome according to the two persons walking in front of it, and maybe put the following in later. And all those nodes are basically like a small computer architecture in the computer itself. and they communicate via a bus system via message passing. Now this, what you see down here, you probably can't read the text. That's the node graph of my current Droid. It has the base interface in the middle, so that's the component that talks to the Arduino in the base, and will tell the Arduino go forward, go backward, turn, do something with the dome, open the hatches, stuff like that. And to follow a person, there's a Kinect tracker on the left, there's a person follower node right to the right of it, there's a Kinect person tracker here, and there's a person follower for the dome. So I have a one component that drives behind you with the body, with the wheels, and one component that turns the dome according to where the person is. Those separate components running separately can be shut down and started separately. And the rest down there is a speech recognizer, a dialogue engine that lets the Droid react to certain phrases, an emotion server. I'd like to talk about that in a second, and a sound play node that talks to the sound card and tells it to play a certain wave file. The emotion server is really strange because Micke and I have never talked about this before, but that's exactly what my Droid does, exactly the same as yours. The emotion server basically keeps an emotion state from happy over angry, cranky, feisty to sad, and it will degrade into sad if nobody talks to the Droid. So it will just stand there, and if you talk to it, it will become happy and happier and happier, unless you want the Droid to do something, like open hatches, you know, stuff that actually causes some effort, and then he'll become angry or feisty, because he really doesn't want to do work. So the idea is to have a robot with a personality here. Oh yeah, actually, one thing that I forgot, I wanted to open my talk with a different thing, and I'll bring that here because it kind of fits there. Circa 2009 at my house, it was my birthday, I told my lovely wife, who's sitting right there, you know, as a birthday present, I decided I'm going to build myself an R2D2. Expecting she'd say, isn't that damn expensive? Or doesn't that take a lot of your time? Or are you crazy? What kind of nerd are you anyway? And she just said, hey, do whatever you want as long as it can fetch me a beer from the fridge. And I said, challenge accepted. So that's the basic goal. I want a Droid that can do conventions like this, it's wonderful, but I also want a Droid that greets me at the door and that will fetch a beer from the fridge and that will fetch the newspaper and maybe project a movie, stuff like that. Okay, let me just really quick talk about sensors. The core component of any autonomous robot, because you want the robot to react to its environment, so it needs to see what's going on around it. What I have in my Droid is I have a couple of ultrasound ranges around the skirt so it doesn't run into obstacles. I have a couple of infrared ranges in the feet so it won't go downstairs. It will detect the stairwell. Bad idea to have an autonomous robot in a house with stairs that can actually go down. I have a Microsoft Kinect, or actually an Asus Xtion, which is the same sensor, and I have a microphone, which didn't work that well. Now, the Microsoft Kinect, I'm sure everybody knows it, right? Okay, most people will have it. Right. So it's a 3D camera that projects a pattern and takes a picture of that pattern and sees from the difference that the projected pattern to the gathered pattern has. It will tell you how far a certain spot in the image is. I have a picture of how that looks like later, but let me just show you how to integrate that in a Droid. Because look at this Droid, and those of you who've seen autonomous robots so far, look at the shell and go, where would I put ultrasound, infrared, cameras, and not lose the look of the Droid. I mean, of course, you could put a Velodyne laser scanner on top, for sure. would kind of ruin the effect. So the thing that we basically settled at the Builders Club is the Asus Ixion, which is this 3D camera. And I have a couple of pictures how I integrated that in my Droid. It's basically, you can take it apart. It consists of an aluminum shell, a couple of camera objectives that you can take apart, and a printed circuit board. Now if you take this aluminum shell, and cut some bits off of it, it will come eventually. Here we go. Oh. Okay, anyway. I suggest you'll come up later if you want to take a look at how the sensor is integrated and look at it in the Droid. It's basically fit into the large data port back here, which is about the only way where you can fit an oblong sensor shape in here and actually have it look through something. And it fits quite well. These are two images that show what the camera actually sees. It's a depth map. In this case, the lighter the green, the closer the point. So what you see here is a person holding his hands up in about, say, 1.5 meters to the camera. And what you can also see is the Kinect camera comes with a person tracker. So it will actually see where your hands are, where your legs are, where your torso is, and you can do awesome interaction stuff with the Droid. You can detect waving, you can detect holding hands up and down like this. You can of course track the person in front of you. And so basically what you do if you want to have the Droid follow the person, you just determine how far the person is away and what angle it is, and then you tell the motor controller, turn like this, go fast like that, up to a certain point. That's all there is to it. Okay. The last one, very quick slide about the voice control. It's based on a program called CMU Pocket Sphinx from Carnegie Mellon University. How this works is you have a file where you basically say these are the sentences I want my Droid to recognize, and you run that file through a compiler and tell the speech recognition this is what I want you to recognize, and it will spit out the sentences as you say them. It's also very, very simple. Took me about half an hour to get running. Okay, so that's about it for the autonomous droiding. I'm very happy to take your questions, and I can only say have fun. It's a long journey, but it's a very rewarding one. All right. Thank you very much. Any questions?
When it comes to programming, the first thing that occurs is debugging and error detection. Is there any IDE you use in order to detect errors while programming things?
Well, I gotta say I'm a bit of a fossil there. I usually use Emacs because I'm a Unix programmer.
Okay.
So, and I use a separate terminal and look for segmentation faults, stuff like that. Have a debugger fired up. But the thing that I forgot about, Ross, is that's a very good question. It's programming language independent. You can program ROS in C++, you can program it in Java, and you can program it in Python. And that's very nice, because that enables you to do rapid prototyping like this.
I just want to say about the Arduino. The Arduino also uses its own IDE, and for those who likes it, the program Eclipse has a plugin for the Arduino, and that's what I use. I have my own Subversion server, which is running all the different versions of the software I have in my Droid, because I have a couple of friends in the States and one in Sweden that's also essentially testing it for me. I write something, and I put it up there, and they test it and tell me. So I don't want to run into any more walls, I'll let them do it instead.
Right, some more questions.
How long until you can get the beer?
Sorry, again?
How long until you can get the beer?
Well, my wife is there, I have to be careful. Yeah, I guess, well, I guess I'm going to have him able to drive to the refrigerator in about 3 months.
Maybe it would be easier to install a little refrigerator into him.
That's a good one. The main problem about that beer thing is the geometry of the droid. Whoever thought this thing up did not want to build a real robot. He wanted to build something that looks good. And the thing is, look at where these boxes are. And the arms come out of here. And now think about the geometry of your refrigerator at home. If it's anything like ours, you're going like this. That's not a good way to actually fetch something that has any weight. So,
Check it out of the dome.
could be a good one. We actually have a guy down there at the builder's booth. It's in hall 5, if you want to come along, who has built the drink arm and the drink tray from episode 6. So the obvious next step would be to put a small barrel inside of the droid and pump it up. But don't tell anybody, it's a secret. We're still working on it.